China just reported growing the world's largest silicon carbide crystal, 14 inches across, bigger than anything Wolfspeed or Infineon has put into production. On paper, that is the finish line of a race the West assumed it would win by default. But the companies that grew it are losing money. Not because they miscalculated, because losing money was part of the plan. Before you file that under Chinese startup growing pains, the losses are not narrowing. They are deepening as output rises. That is not a teething problem. That is a signal. Silicon carbide is the material inside every fast electric vehicle charger, every next-generation power inverter, every industrial motor running at frequencies ordinary silicon cannot handle. Whoever controls the substrate controls the cost curve of the energy transition. By the time you understand what a 14-inch boule actually unlocks, and the answer is not what you would expect, you will see why the crystal record and the financial hemorrhage are the same event, not separate problems. Wolfspeed has been in trouble for a while, but not for the reasons most people think. And the industry keeps using a word, consolidation, that sounds neutral. It is not. This is not a story about a manufacturing record. It is about who gets to set the floor and what happens when you set it below zero. Start with why the material is hard. Silicon carbide crystals do not grow the way silicon does. You cannot pull a boule from a melt in hours. Silicon carbide sublimes. It transitions directly from solid to vapor and back at temperatures between roughly 1500 and 2500 degrees Celsius, and the growth runs take days. The result is a cylindrical crystal, and the process is unforgiving. Impurities and structural defects locked in during growth cannot be corrected afterward. Think of the boule as a loaf of bread. You slice it into wafers. A bigger loaf means more slices from the same oven run. The area of a circle scales as the square of its radius, so moving from a 6-inch diameter to a 14-inch diameter does not give you a little more material. It gives you roughly 5 times the usable area per growth cycle. The industry standard has been 6-inch wafers. Wolfspeed and Infineon are in the process of targeting 8-inch production, which is itself a significant engineering push. 14 inches, according to Chinese state media and industry sources, is what China has now reported. That claim has not been independently verified at commercial production volumes or confirmed defect density. But even as a reported milestone, the number restructures the conversation about who holds the cost advantage and by how much. That advantage matters because of who built their entire strategy, assuming it would not exist. Wolfspeed is the largest dedicated silicon carbide manufacturer in the Western world by revenue. It staked that position on a straightforward premise. Silicon carbide wafers command a steep premium over ordinary silicon because supply is genuinely constrained by how difficult it is to grow defect-free crystals at scale. The premium was the return on the difficulty. So Wolfspeed borrowed heavily and committed to a multi-billion-dollar expansion, the Mohawk Valley fab in New York and the Siler City Megafab in North Carolina, premised on electric vehicle demand growing fast enough and silicon carbide prices holding high enough to service that debt while the fabs ramped up. The bet made sense when substrates were scarce and priced accordingly. Think of it as a specialty coffee roaster who invested in a massive new roastery, assuming single-origin beans would stay expensive. Then commodity producers flooded the market. Wolfspeed's debt load is real. Its stock has faced sustained pressure, and its expansion is ongoing. The floor its entire financial model was built on is the floor now being lowered. The lowering is not one company's doing. That is the part that changes the scale of what you are looking at. Multiple Chinese silicon carbide producers, including SICC in Shandong and TankeBlue, among reported others, scaled capacity simultaneously, with what trade press and industry reporting describe as state support, though specific subsidy amounts are not publicly confirmed. The effect was a wave, not a ripple. Domestic Chinese silicon carbide wafer prices fell sharply as supply outpaced demand. Reports and analyst observations describe a significant decline, though precise percentages with clean sourcing are not available. If a dozen bakeries all receive flour subsidies and open simultaneously in the same city, the bread price collapses even if every bakery is losing money individually. That is the structure. And this is where the answer to the original question snaps into focus. Why would China subsidize an industry into losses? Only if you assume profit is the goal. If the goal is market position and rival exit, losses are not evidence the strategy is failing. They are the cost of executing it. Here is where honest skepticism earns its place. The 14-inch crystal is a reported milestone. Growing that crystal in a research or pilot setting and producing 14-inch wafers at commercial volume with acceptable defect density are two different engineering problems, and the second one has not been publicly confirmed. Chinese 6-inch and 8-inch silicon carbide wafers are in production and shipping. That is reported and consistent with industry observation. The 14-inch claim is best understood as a capability signal, not a confirmed production reality. Beyond the crystal itself, there is another choke point the price war cannot dissolve overnight: qualification. Automotive Tier 1 suppliers typically require 2 to 4 years of demonstrated reliability data before they will certify a new substrate source. Wolfspeed holds years of that data with major automakers. Infineon does too. A new supplier, regardless of price, cannot simply hand over a wafer and replace an incumbent. The qualification cycle is its own barrier, so the dismissive read is wrong. The strategy does not automatically fail, but the triumphalist read is also wrong. Chinese silicon carbide has not matched leading Western quality specifications at every node, at least not in any publicly confirmed independent comparison. The price war pressures rivals. It does not instantly substitute for trust built over years of delivered reliability. What it does do is apply pressure to a competitor carrying expansion debt while margins compress, and that structure has a precedent. China ran a version of this playbook in solar panels: coordinated capacity surge, price collapse, foreign producers exit or contract. China holds the structural position in a critical supply chain. Western solar manufacturers mostly shrank to niches. The same pattern unfolded in light-emitting diode lighting and lithium-ion batteries. Silicon carbide is harder. The crystal physics is more demanding. The qualification barriers are stickier. The customer relationships run deeper. Those differences slow the strategy. They do not make it structurally different. And consolidation, the word the trade press keeps using to describe what is happening in silicon carbide. That word means foreign exit, not neutral market adjustment. The exit of producers who cannot sustain subsidized loss competition. Here is my honest read. The triumphalist framing, China has already won silicon carbide, overstates it. Quality gaps are real. Qualification timelines are real. Wolfspeed and Infineon are not finished. The dismissive framing, subsidized losses prove the strategy is incoherent, misreads the design entirely. My read is this: the win is structurally real, the timeline is genuinely uncertain, and Wolfspeed's survival now depends on a variable China does not control. Whether Western customers or governments decide that silicon carbide supply security is worth paying a premium to protect. The asymmetry at the center of this contest is not technical, it is temporal. China has state backing and a long-time horizon. Wolfspeed has bond markets and a short one. That gap is the actual contest. China did not just lower the price floor, it lowered the floor below the level any unsubsidized producer can profitably stand on, then kept building. The 14-inch crystal and the operating losses are the same instrument, played at the same time, on purpose. Here is what I want your honest read on. Does the Qualification Moat, the years of reliability data Wolfspeed and Infineon hold with automotive customers, actually protect them long enough for the price war to exhaust itself? Or does a wide enough price gap eventually overwhelm even that? Both sides are genuinely defensible. Tell me which one you think holds in the comments. Subscribe. We are tracking this specific contest, whether Chinese silicon carbide quality closes the gap fast enough to matter, and whether Wolfspeed's next earnings call shows the floor finally cracking. That 14-inch crystal is being sliced into wafers and sold below cost somewhere in China right now. The record is real, so is the loss, and both were the point.